Now we're doing FreeCodeCamp Legacy Python for everybody. Objects inheritance. All right. So in the last video, I got a little heated about some situations. Like I said, I don't mean nothing by any of that. I'm just a hot-headed guy. If you haven't noticed, that's like my character flaw. What can I do? You know, all I can say is it's not going to stop. But, you know, I don't mean nothing by it. That being said, here we go. So, let's go.
So the last topic we'll talk about here in object orientation is the notion of inheritance.
Okay, inheritance. Let's write that down. So we got our notes here. We're going to come down here. I'm still in the same day, so I'm just going to do inheritance. I'm just going to type inheritance right down here. All right, so inheritance. All right, let's go.
And this is a form of code reuse, and it's one of the more advanced aspects of object-oriented programming. So just kind of understand what it is at a high level, and then you know where to come back to when you need to learn a bit more about inheritance.
Okay.
So
this is just not a refresher. What's the word? It's just an exposition. It's just to expose us to this, I guess. When we make a new class, we can reuse an existing class and inherit all the capabilities of an existing class. We need to drop this down. Where though? Right here? We'll drop it down here. All right. Existing class. And then add our own little bit to make our new class. What? Why is class 3 times in a row? Okay. Another form of store and reuse. This is another form of store and reuse. Oh, we can write it once and reuse it many times. True. The new class with a child has all the capabilities of the old class or the parent, and then some more. Okay, so when we make, let's look at this. When we make a new class, we can reuse an existing class and inherit all the capabilities of an existing class, and then add our own little bit to make it our new class. Okay, so when we inherit, so if it's a new class, what? So we're going to make a new class that's inheriting an existing class's stuff. So everything that was in the old one is in the new one. And then we can add whatever we want to the new one, because why not? We could add it to both of them. It doesn't matter. If we add it to the old one, it's going to be in the new one. But we can add to the new one and it won't be in the old one. There we go. That's how that works. Another form of store and reuse. Okay, write once, use many times. Yes. The new class, the child, has all the capabilities of the old class, the parent, and then some more, just like we just said up here. All right, great. Let's go.
the idea is, instead of making a new class from scratch, we actually make a new class by starting with an existing class.
Yeah, it's just like programming in general. You don't... I mean, how many times do you got to write, the sort method before you say, well, I'm going to use this twice, I'm going to use this again, and I'm never going to write the sort method again. I'm just going to say sort, I'm never going to write like bubble sort and whatever. I'm just going to use the sort method. Basically the same thing. Just keep building upon that which was built.
class. We are extending it, or another word for this is subclassing. And it's sort of a situation where you're like, I've got this code and I've got this data and I just need to add a few things to it and then I'll have a whole new thing. And as you design objects and what we call object hierarchies, you often do this. And it's a form of sort of real clever code reuse. But again, don't necessarily think that you're supposed to know when to use this or why to use this. Right now, it's just terminology.
Yeah, for sure. Also, if you think about it, sometimes you're going to have to take stuff out of a class. You know what I'm saying? And so, you're going to have to write some sort of remove the function from the class kind of thing, or not use it. I don't know. I don't know how that works. We'll have to figure that one out too. Because look, as we all know, everything has trade-offs, right? You gotta, like, we've got such a complex system going on that it's hard to see the trade-offs. But everything has trade-offs. Like, if you're going to go right, you can't go left, and that's the trade-off. That's one simple trade-off right there. If you're going to go forward, you're not going to be going backwards. Stuff like that. So we'll see what the trade-offs are when we get into this. Let's go.
Okay, just terminology. We have what call these as parent-child relationships. The original class is called a parent, and the new class is called the child class.
True.
So subclasses are.
All right, let's write this down. Boo, boo, boo. I love this so much more than formatting this crap. This is so much of a pain, but whatever. Let's do this. Terminology. Inheritance. Isn't that what we have here? Hold on. We're not going to do that. We're just going to make another one. Subclasses are more specialized versions of a class. Which inherit attributes and behaviors from their parent classes and can introduce their own. Okay, so I guess there's a class and then we can do a subclass. Yeah, that makes perfect sense. Period. Let's go.
Another word for this, you have a class and then you subclass it. I think extending and inheriting and parent-child are probably better ways of expressing it than subclassing. So here's a bit of code.
Who knows? Just say what you want, honestly. So let's get this stuff down. Oh. Can we reuse anything? Sort of. Let's see what we can do. All right, let's get the notes out. So what should we do here? What do you think we should do here? Well, let's do example. Let's do example. Let's say example. How about that? Let's go example. Give me a second. All right, we got example. Let's actually drop this down one too so we can differentiate it. And then let's bring this over like that. So we're going to have class PartyAnimal. Let's go try to grab something. All right. We can do this. We can kind of do this. Yeah, we can take this whole top part right here. What are we going to call this? Football fans. Let's call it, I don't know. Let's just take it. Drop it. All right. So let's call this footballfan.py. Footballfans.py. Why not? Football fans. There we go. Great. He goes to, he teaches at Michigan, so he's got to be talking about American football. This can't be another soccer freaking thing. It can't be. It can't be. I just refuse to believe that. All right, so let's rename this Nam. Back in Nam. All right. Okay, so we got that. Now let's see. Can we take that? We surely can. So let's take this too while we're at it. Let's drop this right there. Get rid of this and get rid of this. Okay, so we got all this like we used to. Now, class football fan party animal. Okay, so this is how we make a new class. Cool. Class football fan. Party animal. Party animal. Okay, so we put the parent over here and we put the child over here. That looks pretty straightforward, in fact. Okay, points. Yeah, it's definitely American football. Points equals 0. Def. Touchdown. Whoops. Touchdown. Self. Can we come here? No. 1, 2, 3, 4, 5, 6. All right. Self points. I'm gonna copy this too. Watch. Copy this. We need 2 more. 1, 2. Boom. All right. We're good. Now let's do self points. Self dot points equals self dot points plus 7. That's not how a touchdown works, but okay. Self dot party. Okay, like that. And then we also got print self dot name. And then we got points here. And then self dot points. Okay. So what this is going to do, we'll do that in a second. So if we call it like, what is this? Okay. Let's do this. S equals party animal. And then we'll say inside of here, whoops. Say inside of here, Sally. And then we'll go s.party. And then down here we'll go J equals football fan. And it's going to be Jim. And what else? J.party, J.touchdown. J.party, J.touchdown. Boom. All right, so this is going to be making a party animal instance for Sally. And it's going to be equaling S. And S.party is going to add, is going to print Sally 1. Sally, what? What? I don't know what this is going to do. What? What did it do up here? All right, Sally constructed Sally party count. So Sally okay. So it's going to do this. It's going to do Sally constructed. It's going to say Sally constructed Sally party count 1. Okay. True. That's what happens when this goes down. And then we're going to have J equals football fan Jim. So we're going to do Jim constructed Jim party count 1. And then we're gonna do a touchdown, and it's gonna say Jim 7 points. Just like that. All right, I think that's what's gonna happen. So let's do that. So this thing right here. Let's put this. Let's go like this. All right, let's say, so this is going to say like this. This is going to go, Sally constructed. Sally party count 1. Okay. And then what's going to come down here, and we're going to say Jim constructed. Jim constructed. Jim party count 1. Jim party count 1. And then we're going to say Jim points 7. All right. And that's what's going to come out. And let's see this. FootballFan is a class which extends PartyAnimal. Hold on. What's going on here? All right. And let's write that here, I guess. FootballFan is a class which extends PartyAnimal. It has all the capabilities of PartyAnimal and more. True. So it's got the power. It does what PartyAnimal does, and it does what touchdown. It does touchdown as well. Okay, cool. Hold on. Wait, we did call touchdown. Yeah, so we called touchdown, and it does Jim 7 points. So this happens. Let's bring this up. Let me do something thusly. Let's do this. Let's do this. Let's do this. And let's do this. Like this. And let's do this. And let's do this. All right. And then let's do. Yeah. Okay. I'm going to take this. All right. And then here. And then here. Okay. So this is what's going on. So this constructs J FootballFan Jim. This is going to construct Jim. Yes, because the initial thing it does whenever it initializes is it says constructed, right? So this is what's going to happen. Okay, cool. Let's go.
Let's take a look at this. This code's unchanged. It's the PartyAnimal code that we've been saying all along. It's the one that we construct and put a name in.
True.
And now what we're going to do is extend it. And so you'll notice that this code down here is the part that's doing the extending. So we're making a new class, FootballFan, and by putting in parentheses before the colon, PartyAnimal, that says FootballFan inherits everything that is PartyAnimal, meaning the X, the name, the init, the party, all those methods and data are sitting there. And now we're going to add a new variable. So FootballFan has, in addition to all those other variables, it has points and it has a touchdown method.
True.
And, self points is added, we add 7 to the points and then we call the party. and that does that. So this is calling this method because FootballFan includes X, name, and party, and init, and everything, and all this stuff, this constructor. So this FootballFan is really an amalgamation of all these things together. PartyAnimal is just this stuff, right? And so we still have two classes. We don't just have one. We didn't erase the PartyAnimal class. And so if we take a look at the code that we can run here, we can say, oh, okay, let's make a PartyAnimal Sally. And so that constructs an object like this and then stores that in S. And with an X starting out 0. And then we call S party. Oops, better change that color.
I'm getting confused. Like, we literally just went over this, and like I feel like maybe not everybody would understand what's going on here, but I feel like this makes pretty simple sense. And then this guy starts talking, and I'm like, what?
Starts out at 0,
and we literally just learned this.
Changes it to 1. Okay, and so this bit of code, it's as if this part doesn't matter at all because it is a PartyAnimal. It's not a FootballFan. But now if we take a look at this code down here, take this code down here, we're going to construct a FootballFan and pass in Jim. But FootballFan has no underscore init, so that actually uses the underscore init from PartyAnimal because we extended PartyAnimal to make FootballFan. So we inherited all of the good that was in there. So there it's going to make a name, a variable X, which is going to start at 0, a variable name that's going to have Jim in it, and a variable points that's going to have a 0 in it. So this J variable has more things in it than the S variable has. And so we can call the J party. And if we call J party, that goes here and adds 1 to X, right? So that adds 1 to X. And then we call J touchdown. Well, that comes down in here and adds 7 to the points, right? And then calls party within us. And so self.party is the current object, i.e. self and J are the same thing, right? Self.party. And then it goes up here and passes self in and it adds.
Stop. All right, back up. J party count 1. Yeah, that's what we did. Yeah, what? I was looking at this like, why didn't we do that? And then I'm looking and we did do that. We did it the whole thing.
1 to the X, in this case of this J variable. So this becomes 2. And that's where it prints out, 7 and 2, and away you go. And so it's a way for you to kind of take all this stuff and stuff it.
What's its Y2? Y2 though. What? Why is it Y2 and not just 1? It's 1. It's a party of. Is the party is 2 now that Jim showed up? Let's go talk to ChatGPT about this because I thought I had it down. It turns out, no. Give me a second. Let me pull up the one we were doing. Okay. Here's this. What's the output of this? Let's ask it. What's the output of this? It should know. It should know. True. True. Okay. Gym party count 1. Yes, 1. Well, it's not 2, right? It is 2. What? Okay. What? Okay. New instance of FootballFan is created. Jim is named. Okay. Sub init is called. this sets self.name gym and prints gym constructed. Then jparty is called. I thought we only called it once. Hold on. Yeah, it's called there. Why would it be? Okay, then jparty is called, and then it's 1. All right. Then jtouchdown is called. Oh, is there a party call inside of touchdown? Yeah, that's what the deal is. Yeah, okay. I missed that. Whatever. Okay. That was the only thing I was missing. So yeah, that's what's up. There's a party call right here inside touchdown. So for some reason, the party count gets higher every time there's a touchdown. It doesn't make sense at all, but that's how the program's written. That's okay. I mean, it makes sense because somebody wrote it, but it doesn't make sense that in reality that there would be another party count every time a touchdown happens. Why? Anyway, but regardless, it's how the program was written, and that's how the program works. So, whatever. Let's keep going. Okay, good.
A class by making a new class and just add the extending bits, the bits that are in addition to the other stuff. So like I said,
True.
Inheritance.
All right, let's type this down. So yeah, it's not really that hard once you realize that it's just this, the new class gets all the stuff that's in here also. So you do this and this, and so you just got to make sure not to leave any of this out and not to leave any of this out like I did. But, we all make mistakes. Let's go. Definition. Definitions, class, a template. Class, a template. Attribute. Up. Come on now. Attribute. A variable within a class. Yes. A variable. That's not okay. Variable inside a class. All right. Now what? Method. Method. A function within a class. A function within a class. That's not how we do it. A class. There we go. Now we're going to do object. Object. A particular instance. A particular instance of a class. This is the best group of definitions I've seen in a long time. Very concise. Constructor. All right. Code that runs when an object is created. There we go. And then we also have inheritance. The ability, I gotta fix this stuff, to extend a class to make a new class. There we go. True. Little c, little a. That's not an A, that's an A. All right, great. So we got this. Let's listen to him talk about it.
This is a powerful and wonderful concept. It's a form of...
Back up.
Inheritance is a powerful and wonderful concept.
True.
It's a form of... excellent form of reuse. But basically, the whole purpose of this lecture was so that I could in the future just use these words and you would understand them as compared to... I just want to say method. And I've been saying method all along, and it's high time that I defined it. So let's just review one last time. Class is a template. It is not actually a thing. It is a shape of a thing. And we define it and say, when we make one of these things, it's going to have these variables in it. It's going to have these methods in it. Attributes, variables within a class. Method is a function that's inside of a class.
True.
Object is once we construct a class, we get back an object. And so object here is the snowman cookies. Class is the snowman cookie cutter. And a constructor is a bit of code that sets up our object, our instance, when it first is created. And inheritance is this ability to create a new class, but take all and import and affect all the capabilities of an existing class. So, object
summary. Are we at the end of the chapter already? Are we almost done? All right, summary. All right, object-oriented programming. OOP, yes. What about it? Is a very structured approach to code reuse. We can group data and functionality together and create many independent instances of a class. True. All right, let's go.
Object-oriented is awesome. For the rest of this class, we're not going to write any object code. We're not going to use class at all, but we are going to use objects. And literally, you've been using objects from the beginning of this course. True. As soon as you said print, whoops, as soon as you said, x equals high, that's an object. And as soon as you said x dot upper, you were calling a method, right? You've been calling a method all along. When you're doing something like fh equals open, this thing you're getting back, that's an object.
True.
And then you do fh.read or whatever.
That's a
you're
method.
calling a method in the dot operator. So you've been using objects all along.
True.
I now am just finally explaining to you when I say call the read method or call the upper method or what's this little dot and why is that there? So again, it's time for us to understand that, but it will take you a long time before you encounter a problem that's large enough where as part of your solution, you're going to make a new object. But when you do, it's really a powerful thing. I mean, it's a really bad idea for me as a teacher to say, oh, write a bunch of objects. It's like, it's premature for that. It's later is when you will actually learn how to use objects and you'll be like, oh, thank heaven that these objects are here. Okay?
Okay.
So that's all for now. Thanks for listening. See you on the net.
See you on the internet. That's not the end. They can't be. What is inheritance in object-oriented programming? A new class created when a parent class is extended. The ability to create a new class by extending an existing class. I like that. A constructed instance of the class. No, that's an object. A method that is called at the moment when a class is being used to construct. That's an initialization. So yeah, this one. Looks good and submit it. All right. So now we're on to rational databases and SQLite. SQLite, whatever that is. And we'll see you next time.